Have you ever wondered why some countries seem to have all the luck? We're talking about places overflowing with oil, diamonds, and lush forests, while others struggle with scarce resources. Is it just random chance? Or is there a bigger story behind it? What if I told you that the ground beneath your feet, the air you breathe, and even ancient history are all part of a giant planetary puzzle that decides who gets what? Get ready, because we're about to embark on a global treasure hunt. We'll uncover the secrets of why Saudi Arabia sits on a sea of oil, why Brazil is home to the world's largest rainforest, and why some nations have vast reserves of freshwater while others face deserts. This isn't just a geography lesson. It's the story of wealth, power, and survival. Stick around because by the end of this video, you'll see the world map in a completely new light. The answers will surprise you. So, what exactly are natural resources? Simply put, they are materials or substances that exist in nature and can be used for economic gain. Think of them as Earth's pantry. This includes everything from the obvious stuff like minerals, fossil fuels, and timber to things we often take for granted, like fertile soil, clean water, and even the wind that powers turbines. We can group them into two main categories: renewable and non-renewable. Renewable resources are the ones that can replenish themselves over a human lifespan. Think of forests that can be replanted, fish that reproduce, and solar energy that, well, comes from the sun every day. On the other hand, non-renewable resources are finite. Once we use them up, they're gone for good, or at least for millions of years. This category includes fossil fuels like coal, oil, and natural gas, as well as minerals like gold, copper, and iron. The fact that these are limited is a huge deal, and it's a major reason why their location is so critically important. Now for the big question: why aren't these resources spread out evenly like butter on toast? Why is the distribution so incredibly lopsided? The answer lies in three key factors: geology, climate, and time. Lots of time. Let's start with geology, the foundation of it all. The Earth's crust is not a single solid shell. It's made up of massive tectonic plates that are constantly moving, crashing into each other, pulling apart, and sliding past one another. This movement is the master architect of resource distribution. Take fossil fuels, for example. Oil and natural gas are the remains of ancient marine organisms, like plankton and algae. Millions of years ago, these tiny creatures died and sank to the bottom of ancient oceans. Over time, they were buried under layers of sediment. The immense pressure and heat from these layers cooked the organic matter, transforming it into the hydrocarbons we call oil and gas. This is why major oil reserves, like those in the Middle East, the Gulf of Mexico, and the North Sea, are often found in regions that were once vast, shallow seas. The specific geological conditions, the right kind of rock to trap the oil and a source of heat, had to be perfect. The same geological drama creates mineral deposits. When tectonic plates collide, they can create massive mountain ranges. This process, called orogeny, involves intense heat and pressure that can melt rock, allowing minerals to concentrate and form valuable veins. This is why you find resources like copper in the Andes Mountains of Chile and gold in the mountain ranges of South Africa and the western United States. Volcanic activity, another result of plate tectonics, also brings precious minerals from deep within the earth up to the surface. Diamonds, for instance, are formed under extreme pressure deep in the Earth's mantle and are brought to the surface by rare volcanic eruptions. Now let's shift our focus to climate. Climate is the long-term weather pattern in an area, and it's the primary driver for the distribution of biological resources. The most obvious example is forests. Tropical rainforests, like the Amazon in South America and the Congo Basin in Africa, thrive near the equator where it's consistently hot and rainy all year round. These conditions are perfect for dense, rapid plant growth, creating incredible biodiversity and vast timber resources. Move away from the equator and the climate changes, and so do the forests. In temperate zones with distinct seasons, you'll find deciduous forests. Go further north, into colder climates, and you'll find vast coniferous forests, known as the taiga, stretching across Canada, Scandinavia, and Siberia. These forests are major sources of softwood lumber. Climate also dictates the availability of one of our most precious resources, freshwater. Global rainfall patterns determine where rivers flow and where groundwater aquifers are replenished. Areas with high rainfall, like the tropics, generally have abundant freshwater. In contrast, regions located in rain shadows of mountains or in subtropical high-pressure zones become deserts, like the Sahara in Africa or the Atacama in Chile, where water is incredibly scarce. And of course, we can't talk about climate without mentioning agriculture. The type of crops that can be grown in a region is entirely dependent on its climate, the temperature, the amount of rainfall, and the length of the growing season. This is why the Midwestern United States is the world's breadbasket for corn and soybeans, while Brazil is a powerhouse for coffee and sugarcane, and Southeast Asia dominates rice production. The climate creates a specific agricultural niche for each region. Now let's tie it all together with some real-world examples. Let's look at a resource-rich area like Australia. Geologically, it's an old and stable continent, which has allowed vast deposits of iron ore, coal, and uranium to accumulate over billions of years. Its varied climates, from tropical in the north to temperate in the south, also support a wide range of agricultural activities. On the flip side, consider a country like Japan. It's a volcanic island arc, which means it's geologically young and active. While this creates stunning landscapes and hot springs, it doesn't provide the stable, ancient geological formations needed for large deposits of fossil fuels or minerals. Japan has very few domestic energy resources and must import almost all of its oil, coal, and natural gas. This has driven Japan to become a world leader in technology and energy efficiency, a classic example of how resource scarcity can spur innovation. And what about human activity? We are the third major factor influencing resource distribution, especially in the modern era. Through technology, we can now access resources that were once unreachable, like oil buried deep under the ocean floor. Our consumption patterns also drive demand. The global appetite for smartphones and electronics, for instance, has dramatically increased the demand for rare earth minerals, found primarily in a few locations like China. However, human activity also depletes resources. Overfishing can collapse entire fish populations. Deforestation for agriculture can destroy vital ecosystems and timber reserves. Pollution can contaminate freshwater sources, making them unusable. Our actions can drastically alter the availability of resources for future generations. The uneven distribution of these resources has profound effects on global economies and geopolitics. Countries rich in high-demand resources, like the oil-rich nations of OPEC, can wield significant economic and political power. This wealth can fund incredible development, building modern cities in the desert. However, it can also lead to what's known as the resource curse, where a country becomes overly dependent on a single commodity, neglecting other sectors of its economy and sometimes leading to corruption and conflict. Conversely, resource-poor nations must rely on trade and innovation to prosper. They often develop strong manufacturing or service-based economies. Think of countries like South Korea or Switzerland. They have few natural resources but have become global economic leaders through technology, finance, and skilled labor. So, the next time you look at a map, don't just see borders and names. See the ancient oceans that became today's oil fields. See the colliding continents that pushed up mountains of minerals. See the climatic zones that painted the globe with forests, deserts, and farmlands. The distribution of natural resources is a complex and fascinating story written by geology, shaped by climate, and constantly being rewritten by humanity. Understanding this story is key to understanding the world we live in, the challenges we face, and the future we are building together. Thanks for joining me on this journey around the planet. If you found this explanation helpful and want to learn more about how our world works, make sure to hit that like button and subscribe to the channel. Let us know in the comments what other global topics you're curious about. See you in the next video.